Hi, everyone, and welcome to Forestry Fridays. My name is Beth Hill, and I'm the Outreach and Education Manager for the North Dakota Forest Service. I have a background in soils, and I worked previously as a soil scientist with the Natural Resources Conservation Service. When considering a windbreak, whether that's a new establishment or a renovation, the soils data can provide us with a lot of information on that site and give us some insight on how we might expect our trees to perform. However, I know sometimes we can run into issues understanding what that data is telling us or what all we can do with this data. So today I'm going to help you figure out what to do when Web Soil Survey seems to let you down. I bet if you rummage through your local NRCS field office, you will probably find one of these bad boys. These soil surveys were thick paper books chock full of historic information, soil descriptions, lots and lots of maps, and interpretive tables that help you to best manage your soils on your land. Soil surveys describe the kind of soils that exist in an area. Soils are described in terms of things like location on the landscape, profile characteristics, relationships to one another, suitability for various uses, and/or needs for particular types of management. The art of soil mapping began with soil scientists taking aerial imagery and drawing out polygons where they could group soils based on those factors. They then would go out and ground truth their predictions. In short, the lines that those soil scientists drew are the base for what we see on Web Soil Survey today and what we use to make our land management decisions. Because it would be impossible and incredibly time-consuming to draw out each and every soil on a map, soils are grouped into map units for display purposes. Each individual area of soil on a map is a delineation, and soil delineation boundaries are drawn wherever there is a significant change in the type of soils. I think it's important to understand that these are not hard lines. You're not going to put 1 foot into this map unit and 1 foot into this one and have 2 distinctly separate soils. These lines are a gradual change, and the map units are meant to group similar soils. Soil delineations typically relate to the underlying landform, like the floodplain, backslope, terrace. Delineating out too many soils would make the map messy and very hard to read. Soil maps have their own language, and I will do my best to explain how to read them. It's important to note that these soils were mapped at a 1 to 24,000 scale. For most tree plantings, the scale of the planting is considerably smaller than the scale of the soil map unit as identified on the soil map. Our polygons or delineations are called map units. These map units are composed of a number of different soil components, which are the individual soil types within the polygon. Each soil component is unique from one to another, and things like its horizons, textures, parent material, and landform position help to determine what soil it is. Each map unit has a map unit symbol, which is usually a mix of letters and numbers. The map unit name correlates to one specific map unit symbol. This map unit name can provide us with further information about the soils that are out there, including the major components, surface texture, any modifiers like gravelly or saline, and the slope. Here I have a clip of a soil map with the map unit legend on the left. We can see that the closed depression map unit here on the right has a map unit symbol of F4A. That symbol corresponds to the map unit name Southam Silty Clay Loam 0 to 1% slopes. This tells us that the majority of the F4A map unit is composed of the Southam soil component. That doesn't mean we only have the Southam soil in this map unit, but the Southam soil is the one that takes up the majority of this map unit. The surface texture is silty clay loam, and the slope is 0 to 1%. Similarly, we can see F143C right here, which corresponds to the map unit name Barnes Buse Langhigh Loams 6 to 9% slopes. This tells us that we have 3 major components: the Barnes soil, the Buse soil, and the Langhigh soil. There exist other components within this map unit, but the components that make up the largest portion of this map unit are these 3. We can also see that we have a loam surface texture, and our slopes are steeper, 6 to 9%. Within our soil surveys, we also have interpretations, which act as guidances on how these soils could be expected to perform in different land uses or classifications based on those properties. These interpretations teach us how to best manage our soils. In older soil surveys, interpretations were given for each map unit based on the most limiting interpretation, or what we call the dominant component. Web Soil Survey expands upon that and provides properties and interpretations for each component in the map unit, along with the percent composition. The user can decide how to aggregate the data: dominant condition, dominant component, most limiting, least limiting, or weighted average. When considering windbreak establishment, one interpretation we turn to is called conservation tree and shrub group. Each tree or shrub species has certain climatic and physiographic limits. Within these limits, a tree may be well or poorly suited to a site because of soil characteristics. These groups, numbered 1 through 10, designate restrictive features or lack thereof within the soil profile that would impede growth of different tree species. These features can be sandy textures, root restrictive layers, drainage class, and more. Species are grouped according to expected height growth at 20 years given good management. This includes the control or near control of competing vegetation. It is assumed that by 20 years of age, a tree or shrub planting is providing the planned for benefits. After establishing the CTSGs, trees and shrubs are assigned to each group using published references, direct observation records such as the National Forest Soil Database, to determine which species have been observed on soils within a CTSG. When no data is available, publications, personal experience, and local field observations are used. We have all of the data that was traditionally available in the soil surveys available online in a platform called Web Soil Survey. This is an online database that can be accessed by whomever, wherever. It's a very user-friendly, updated regularly, and there are tutorials available on this main page if you want to become a WSS master. So I will walk you through how to best find the information we need for determining if tree planting can be successful on your selected site. So first, we start by typing Web Soil Survey in your search engine or save it to your bookmarks bar, which will bring you to this main page. Click the big green button to begin. First, you're going to input your selected site. This can be either by address, PLSS, lat long. I'm choosing a site near Bowbells up in Burt County. When you click View, it's going to zoom to the location you just entered. Next, you're going to select your area of interest. You're going to select one of these polygon tools up at the top toolbar. I chose the square AOI tool, and I'm going to draw a rectangle around the area I want to do my planting. You will then come to a screen like this with blue-green lines across your AOI. Next, you're going to hit the Soil Map tab up here, which will take you to a screen like this. You have your map legend on the left-hand side with all of our map unit names and symbols, as well as a soil map here on the right. So say, for example, we want to renovate this tree row here in map unit 2179, where we would have some gaps. I'd first stop to think, why would there be gaps? Did we have trees planted there initially that struggled or didn't make it? Is it a management issue or a soil issue? What species was planted there before? What looks good out there right now? This is a great opportunity to talk to the landowner. This may help answer some of those questions right off the bat. If it proves to be inconclusive, then we can turn to the soil map and interpretations for further investigation. Here we start off with some great information about the setting of our site. We have things like mean annual precipitation and temperature. We have our map unit composition, which says our first major component, that Noonan, could be expected to compose roughly 50% of the map unit. The Nile bell is also a major component and can compose about 29% of the map unit. That's about 80% of our map unit in total, with the remaining 20% as our minor components. These are found on the landform in association with the Noonan and the Nile bell, but to a much lesser degree. Okay, so let's learn about that Noonan soil. Here we can see that this soil sits on the flats of our landform, and it developed from a fine loamy glacial till. That means we can probably expect some more clay loams in the profile if the parent material was fine loamy. And we can see that reflected in the breakdown of the soil profile here. We have loam in the surface and clay loams throughout the rest. These letters within the typical profile section are also a part of our secret soil scientist language, but don't let that scare you. Becoming familiar with a few of the common symbols for horizons in a soil profile in your area can help you determine what CTSG you're dealing with in each soil component. This does take some practice. One thing I look at is the depth to restrictive feature. Here for the Noonan soil, it says 5 to 10 inches to natric listed. This means in this soil, we see an accumulation of sodium between 5 and 10 inches, which creates a clay pan that restricts root growth and water movement, often referred to as alkali spots. This would absolutely limit a potential tree's root growth. If we scroll down, we can see the characteristics of our other major component, the Niobel soil. We can see this soil is found on the rises on the landscape and also developed from the fine loamy till. It has similar textures as the Noonan throughout. Let's look at that depth the restrictive feature section again. This time it says more than 80 inches. That's great. So within this map unit, yes, we do have a soil that could prove tricky for tree planting due to restrictive features, which is the Noonan soil. But the other major component in the map unit, the Niobel, may not have these same issues. And if we look further down, we see our minor components. We have the Williams, Miranda, Tonka, Hamerly, Heil, and Parnell. Okay, so now we have made ourselves familiar with some of these soils that we could expect out there in our selected tree row. Let's compare this with some interpretations so we can find the right tree for the right place. Let's do this by selecting the Soil Data Explorer tab at the top. Next, you're going to make sure to select the Suitabilities and Limitations for Use tab here. You are then going to click on Land Classifications here on the left, and then open up the Conservation Tree and Shrub Group tab. As you can see here under the table, the aggregation method for this interpretation is dominant condition, not dominant component. You can change this under Advanced Options on the left if you choose, but with dominant condition, it takes all of the components into consideration, not just the most limiting. We can see here that the 2179 map unit, the Noonan Niobel loams 0 to 6% slopes, has a CTSG rating of 9N. If we look up 9N, that designation means that the subsoil exhibits a layer with clay pan characteristics within 6 to 18 inches of the soil surface. It has an electrical conductivity that is less than 4, and the water table is greater than 18 inches from the surface. This means that there is some restrictive properties in our soil that could hinder the establishment and growth of certain trees if they were planted on this soil. But does that mean that every soil in the entire map unit is a 9N? Absolutely not. Remember that the Noonan was only 50% of our entire map unit, roughly, meaning that we can have other soils that could have other CTSG ratings out there. And since the map we are using is at a scale of 1 to 24,000, we can't trust that this small section of the tree row is for sure that Noonan. So what can we do to investigate further? Let's use another interpretation that you may not be as familiar with. Click on the Soil Reports tab up at the top here. That will bring you to a page like this. Again, click into Land Classifications and then into Conservation Tree and Shrub Groups. You can click the Include Minor Components checkbox and then View Soil Report. And you will come up with a not as colorful map with a table underneath it. It's important to note again that this warning pops up. Soil map may not be valid at this scale. So let's look again at that 2179 map unit by scrolling down. So this interpretation also gives us the CTSG rating of our map unit, but it breaks it down further and lists them individually by component. This can be helpful in getting a better picture for our specific site at the scale we need before we go out and do some ground truthing. We can see here that the Noonan we looked at with the 9N rating. Our Niobel is our other major component, and it actually has a CTSG rating of a 4, meaning we basically have a loamy surface texture with a clay subsoil. A lot more kinds of trees are able to grow on a 4 than a 9N. Even still, our map unit also could have some Williams, which is a 3, Tonka, which is a 2, or a Hamerly, which is a 2KK. It's important to note the other minor components as well that have even more restrictions, like the Miranda, the Heil, or the Parnell. Maybe the gap we're looking at here is shallower, where we could see the Natric Miranda soil, and that indeed would be considered a 10? Or is it more like a depression where we might see a more poorly drained soil like a Heil or a Parnell? Another thing to note would be looking at the adjacent map unit, that 2181 Miranda Noonan loams 0 to 3% slopes. It has its major components as Miranda at 54%, which is that shallow and natric soil profile classified as a 10, as well as the 9N Noonan at 25%. But here we see a pretty decent tree stand. If we go out on site, dig a few holes along the tree row, we could see that we have soils that could actually support tree growth. Maybe it's more of a CTSG 4 or 3 on that specific section of that landform. You wouldn't know until you get out and take a look on site. All of these assumptions and educated guesses can be made from what we've seen on Web Soil Survey, but in my opinion, you really can't draw solid conclusions until you put some boots on the ground. Nothing can give a better indication of the site potential than looking at that site. And I know just how hard it can be to feel like you're stuck in the office with paperwork. That just gives you an even better excuse to get out and walk the land, dig a few holes, and talk with the landowner. I want you to meet your new best friend, your sharpshooter. Your other best friend will be this guy, the Soil Field Guide for Identifying Conservation Tree and Shrub Roots. It was designed to be used in the field by individuals with limited soils experience. Knowledge of texture by feel method and several key soil features will enable users to assign tree and shrub groups in the field. Soils are defined by a range of characteristics that change gradually over the landscape. Determining where to examine the soil will greatly influence your outcome. Always choose a representative site within the area of investigation. Historic aerial imagery can be helpful. Web Soil Survey's imagery is just a snapshot in time. By going through previous years, you can see changes in precipitation and how the soils and plants respond to that. Maybe we can see salt crusts in a dry year, but in a wet year, they're not as apparent. Can you see when trees were originally planted? When did you notice them dying off? Was this formerly a cropped field? How did the crop look in that area? Understanding which position on the landscape that your representative area falls can help you determine which soil you're looking at. Soils at the top of the hill, on the summit and shoulder, are going to be subject to more erosion processes, where soils at the foot and toe slope will have more deposition processes. Let's say you have a map unit that has a slope of 0 to 6%. You can start by looking at the soil map and determining which soils you have on your map unit. That will help you become familiar with which soils sit where on the landscape. You can get out there on site and see that the area you want to plant is along this landform. You can dig some holes along the slope in each position to see which soil and which corresponding CTSG is on that position. We use our handy dandy soil field guide for identifying CTSGs and determine maybe we have an 8K here on the top, a 3 here on the back slope, and a 1 here on the foot and toe slopes. Texture plays a big part in determining which CTSG you have. Texturing by feel in the field is going to be your best bet. If you don't have much experience, in the Soil Field Guide for Identifying CTSGs manual, it has a flow chart to help you. Wet your soil and form a ball. Does it hold together? Try to make a ribbon. How long is that ribbon? Now excessively wet it in your hand. What do you feel? Grittiness, smooth, neither, both? This definitely takes practice, but it's one of the most useful tools you can have. I hope this presentation provided you with some insights on how to help you to make the best decisions for establishing new windbreaks or renovating existing ones. It's amazing the impact that soils can have on the success or failure of our tree plantings. Understanding the capabilities of Web Soil Survey is the first step, and then learning what to look for when you go on site is next. You all do tremendous work in the field of conservation, and I hope that you'll be able to help use these tools and tips to improve your decision-making with tree planting. As always, for more information on trees or forest management in North Dakota, you can check out our website, our Facebook, or our Forestry Fridays YouTube channel. We upload new videos every Friday.